Welcome to the Data Hall YouTube channel. We have started a series of lectures on data visualization using ggplot in R. We have already covered the basics of ggplot, and in our previous video we have discussed the categorical variable. So how do we make bar chart grouped or stacked bar chart that are used for single categorical or two categorical variables. In this video, we are going to focus on the numerical variables. We are going to look into the histogram, which is used for a single numerical variable. We're going to look into the scatter plot that shows the relationship of two numerical variables. And then we are going to use the box plot, which we can use for a relationship of a categorical and a numerical variable. And we can also get a look at the distribution and the outliers. Okay, so let's start with the single numerical variable. So first thing first, we need to load the tidyverse library, and when we load the tidyverse library, it loads a couple of libraries along with itself. And so one of the library it would load is dplyr, then it would load ggplot2, which we are interested in this video. Okay, so now we are going to generate a data set. So let's generate a stock price of this ABC stock. This is a hypothetical stock that I have just created. So we are going to generate a data frame which would hold a variable, just a single variable called price. And we are going to generate a random normal distribution data with 3000 observations with a mean of 300 and standard deviation of 50. So this would generate a variable, a random data. So we are going to use this set seed is equal to 1 to 3. So if you want to follow our video and want to have the exact same data and exact same graph, then you might use the exact same seed. So this is used for replication of the data. So okay, so now we have this price data. What we are going to do is we are going to use generate histogram. So use ggplot, specify the data set. Then in its aesthetics, we just have a single variable, that is price. We add upon that a new layer, which is geom histogram. Okay, so this is how the histogram would look like. Now it shows that there is a normal distribution, but do remember that by default the histogram would select a specific bin size, bin width, but we can change the bin width. So if we can change the bin width using this bin width argument. So if we set a quite lower value, then it would not give us the exact idea of the distribution. Similarly, if we increase that to a quite higher value, again, it would not, it would create just few bins, in this case, just 2 bins. And that will also not give us a good idea. So it is ideal to play with the bin width and see which bin width would give you a more better look into your data and generate a better histogram. For this purpose, we can also use density plot, and again the command is exactly the same, except for the geom histogram I am replacing it with the geom density. So this geom density would just give us a line, and this line would tell us whether our distribution is normal or whatever the distribution of our data is. Now it looks quite simple, but we can use this fill argument and let's just say, let's call it red, and I mean it would fill the again it looks somewhat bright, so we can set the alpha and change the transparency of that graph, so it looks more nicer now. So this was just the data that I have generated myself. I would like to play with the density plot using the built-in data set, that is the MPG data. And this MPG data contains the data related to different cars, their displacement, their the type of drive, whether it is a forward drive, four-wheel drive, or a rear drive, its highway mileage, its engine size, etc. So we are going to use the MPG data, and we are going to plot the highway mileage using the density plot. Now it gives us an idea that it is a bimodal data, right? So we have two peaks over here. Now this is just for a single variable, that is highway mileage per gallon, and for the whole data set. But as I showed you that there are different categorical variables. One of the categorical variable that we are interested in is the drive variable, the type of the drive of the car, whether it is a forward wheel drive, four-wheel drive, or a rear wheel drive. So F, 4, or R. So we want to have a density plot for each type of the drive, right? And for that we use this color argument, right? So if I can just remove this fill for now and this alpha for now, right? So we just introduce the color argument with the categorical variable drive. So it would generate a separate density plot for each type of drive, and it would give them a specific color. We can see that they all somehow looks bimodal, but their distribution is somewhat different for each other. But maybe we could also have used this fill, and what that would do is it would fill these graphs with a instead of just these lines having color, these fills of the line, these fills of the graph would have the color. But now what happens is that, you know, they block each other. So this blue, this graph related to the rear wheel drive blocks the green and the pink graph. So what we can do is we can, you know, do some transparency, introduce some transparency, and that we would be able to see the graphs that are behind them. So we have set the alpha argument equal to 5. You can set any value, and that would introduce some transparency into it. So that was a single numerical variable. If we were going to look into the relationship of two numerical variables, then we need to use a scatter plot, right? And so let's look again into the MPG data. So we are going to map these X and Y variable, these X and Y statics. So we have this Y as the dependent variable. So we want to look into the size, the effect of the size of the engine on highway mileage. The geometry that we are going to use is geom_point, which is used for scatter plot. Now this is the scatter plot. We can see that there is a negative relationship. As the size of the engine increases, the highway mileage, the efficiency of the car would decrease, and that makes sense. Okay. Now the color of the marker, we can also change the color of the marker. So as we have this drive variable, we want to have a different color for each type of the drive. So a different color for the four-wheel drive, a different color for the forward-wheel drive, and a different color for the rear-wheel drive, right? So we introduce this color that would be equal to this drive variable, which is a categorical variable. So it would introduce a color for each type of drive. And now we can see that most of the rear-wheel drive are more efficient, and most of the four-wheel drive are lesser efficient, irrespective, I mean, of their engine size, right? They are less efficient, and that makes sense. We can know these colors look fine, but somehow they become difficult to distinguish. So it is better to have shapes as well. What we do is we introduce the shape argument. So we change the shape of the markers based on the drive variable. So along with these colors, we would have a different shape for each type of drive. Now it is not necessary that you would want to have a shape and color for different type of drives. What you can do is you can have you can have more information depicted on the graph. So there is this variable called class, and that represents the class of the car, whether it is an SUV, it is a pickup, or middle-sized car. And what we want is we want to have a different shape for each type of class, but a color based on the drive, and that would give us more information on the graph. But the issue with that is that There are some predetermined shapes, and these predetermined shapes are maximum of 6. So, but in our class category, we have 7 categories, and we omit the first category, the last category, which is the SUV. So we do not see any markers for the SUV category. But again, I have discussed this one in my first video on the ggplot. So go back and watch that video. I would give that a link in the description of this video. We can change the size of the marker. So let me introduce this graph back. So these markers look somewhat smaller. What we can do is we can increase the size of them by using the size argument, and that would increase. Now we are using this specific size, a static size for each marker, but you can have the size depend on certain variables. So we have in our data set a variable called cylinders. So either the car is 4 cylinders, 6 cylinders, 8 cylinders, etc. So the number of cylinders, it is a discrete continuous variable, numerical variable. So what we can do is we can base the size of the circle based on any categorical variable, right? Or numerical variable, sorry. So we want the size of the marker to be based on the cylinders. And if we do that, these are, say, 4-cylinder cars, and as we move towards the higher engine, the number of cylinders would increase. We can have additional layers. Now let me again bring back my basic graph. So now we know that there is this negative relationship between this engine size and highway mileage, but we would want to be able to clearly see, we would want to have a line that would represent that relationship. For that, we are going to use the geom smooth, and this geom smooth would add line over this graph. So this would be the inner layer of graph. Now, in our first video, we have already discussed if you want to have a single line instead of multiple lines, and if you want to remove this confidence interval, you can set that equal to false as well, right? The second thing is that there is this smooth lines, right? Instead of that, we might want to have a linear line, but we would come back to that in a while. First thing is that we want to change the line type. So now they all are solid lines. We might want to have a different line based on the type of drive. For that, we use this line type argument, give it a categorical variable on the basis of which we want to change the line type. So now we have a different type of line for each type of our drive variable. Now, if I wanted to add a single line instead of 3 different lines, remember I have defined all these arguments in the global setting, that is in the ggplot argument, static argument. Now, if you want, what that would do is consider them as a global setting, and these settings would apply to each geom that, or each layer that I introduce into my plot. Now, if I want just to have these colors and shapes for the points and not the lines, so I do not want to have a separate color for each line, then I would have to take these statics from the global setting and introduce them into that specific geometry. This is what I have done over here. I have taken out the color and the shape, and obviously we do not need line type if we just want to have a single line, and paste them in the static argument of the geom point, right? And if I do that, we get a single line. Now it is a curve line, and we do have a standard errors around them. Now we can have a linear model by setting the method argument equal to lm within the geom smooth layer, and we can set standard error equal to false, and that would remove these standard errors, right? Now again we have 3 lines because we have these statics defined over here. So if we can remove these from here and introduce them within the geom point statics, we would have a single line. Next, we would look into how do we work with a categorical and a numerical variable. So if you want to look into the relationship of a categorical and a numerical variable, we use box plot. So how do we use a single box plot? We have the ggplot argument, the data set. Within statics, we just define the single variable that we want to have, and we introduce this new layer, which is geom box plot, right? And that would give us the box plot. Now let's have a look at what this box plot says. Now this box plot contains this horizontal line, which is the median. Then we have the starting point of the box, which represents the 25th percentile. The highest point represents the 75th percentile. And this whole box represents around the 50% of the observations. So it is called interquartile range. Now these lines are called whiskers, and they extend to 1.5 range of the interquartile range. So plus 1.5 and minus 1.5. And anything higher than these interquartile range might be potential outliers, right? So these 2 points seem to be a potential outliers, but we are going to discuss outliers in some other video. Now this is just a box plot for the highway mileage. But if we wanted to add a box plot for each category, so we would have to make multiple box plot based on category. For that, what we do is our y variable would remain same, which is highway mileage, but we would introduce an x variable based again, that x variable would be categorical variable, and the rest of the command remains the same. And this would introduce the different categories of the categorical variable or the x variable on the x-axis. We can compare the median. We can see that the four-wheel drive highway mileage is the lowest one, and the forward wheel drive highway mileage is the median of the forward wheel drive is the highest one. But we do have more outliers in the forward wheel drive. Now it looks quite simple, right? What we want to have is have a different color of outline or different color of the box plot. For that, again, we use the color argument, and we introduce the categorical variable on the basis of which we want the colors to change, and that would change the color and looks somewhat nice. But what if we wanted to have the fill based on colors, right, instead of the outline? Or let's just say we wanted to introduce the fill. Now what would happen is that it would fill, but it would because the outlines and the fill are of exactly the same color, so we do not see the medians, right? So what I have done is I have removed the color argument that is used for the outlines, and now these outlines are black. Now we have all these categories in a single plot, but we might want to have a different plot for each of these categories, and for that we use facet trap, and facet trap divides this plot into different plots based on the categorical variable that we assign. So we use the tilde sign, so based on this drive variable, and if we do that, we get a separate graph for each categorical variable. So I hope that was useful. Thanks for watching this video, and do subscribe this channel.